My name's Chris Colati. I'm here with David Hill. We're going to talk to you guys today about some vCloud architecture, some deep dive stuff. We've done this presentation once already, so we got some feedback. We made a couple of adjustments. We were lucky enough to do this 3 times, so by the 3rd time, hopefully we'll get it dialed right in for everybody tomorrow and then in Copenhagen. So welcome. We appreciate you guys coming first thing this morning. So we were taking bets whether there was going to just be 5 or 6 people or whether we'd actually have a full room. So typical disclaimer that we all blow past. My name's, again, Chris Colati, consulting architect with the Center of Excellence team, I guess is what we're calling it now, inside Bless You. Bless you again. That's okay.
He's awake.
Yeah, he's awake now. So I am a VCDX. I'm VCDX number 37. My Twitter ID is ccolati, and my blog is chriscolati.us. So I'm also presenting a group discussion, and I do have some expert one-on-ones, and we're presenting this one again, and my colleague David Hill.
Yeah, so I'm senior consultant, same team as Chris with the Cloud Center of Excellence. I've been with VMware nearly 2 years now. And I've got my own blog, virtual-blog.com, and my Twitter ID is davehill99 for anyone who wants to follow me or Chris.
I'm not quite sure where that picture came from of myself, but so I'll run through the agenda real quick, and then I'll turn it over to Dave to kick things off. So we're going to talk a little bit about some business requirements around vCloud Director. And then we're going to dive right into the architecture. This is some of the feedback we got. We slimmed down the business requirements a little bit because people wanted to dive into the architecture and leave a little more time for questions. We'll talk a lot about allocation models inside vCloud Director and networking, mostly because those are the 2 most confusing areas that we run into with folks. So hopefully we'll try to confuse you even more as best we can. And we've actually got a couple of customer use cases that we put together just to tie it all together, especially on the networking side. So, Dave.
So just before we begin, who's actually deployed vCloud?
Who's deployed it in production? One guy, John. Cool.
You can answer the questions then. Okay, so to begin with, one of the key business requirements for cloud computing now is obviously the ability to do chargeback and showback. So when you're looking at chargeback, obviously it provides you with the abilities to see how much your IT projects cost, what your return on investments of IT projects are, and also accountability. So previously when you're looking at deploying environments back in the physical days, people were just given a big pot of cash, and then they'd just spend it on whatever they wanted, and IT had no real accountability of what this was. So when you went now with chargeback and the ability to show what projects are costing, it's actually showing that these projects are strategic to the business. So it's a lot easier for CIOs and people like the IT managers to justify this to the business themselves. And obviously chargeback as well allows you to show the true cost of the shared resources, so your storage, your networking, whereas previously, even in virtual infrastructures before chargeback came along, it was just a case of people will spend X amount on storage infrastructure and network infrastructure, and there was no real justification of why it's costing so much. It's just, we need X amount of storage. So with chargeback, it allows you to say that particular departments within an enterprise are using this amount of storage and it's costing us this amount each month, and you can calculate that and show where different departments' costs to the business as well. So some of the key business requirements, obviously Chris and I work in the delivery team, so when we're going out to customers and we're speaking to them, a lot of the business requirements that we're seeing are these ones listed. I won't read through them all, but some of the key ones are the ability to prolong legacy applications. So a lot of people who work in IT come across people who've had servers for a long time. They don't want to release these servers. They like the fact that their application works, or their application is critical to the business, but it's not supported on other platforms. So with cloud computing now, it provides you with the ability to move these out into the virtualized world and to look at the costs and what it's actually costing to run these applications. Business agility is the main key one as well for cloud computing. So it allows you to provide multi-tenancy support. So like some of the big banks that I've worked with, you have 5 or 6 banks under those sort of the group banks, and then you need to be able to isolate these. So in the old days, they used to have physical data centers with all the different banks, infrastructure, air gaps in the data centers, whereas now with cloud, you can actually have it all running on the same infrastructure without having separate clusters and all air gap networking. Self-service capabilities as well is a key one. It allows consumers to come along and just select what and when they want to have their resources, and scalability and elasticity. So you can obviously ramp up resources when you need it, and then when in quiet months in the business, you can obviously reduce down the infrastructure. So we're going to cover the vCloud architecture. So vCloud in itself isn't just one product, it's obviously a whole group of components that fit together. Obviously the key component for vCloud is obviously vSphere. vSphere is the underlying component that provides all the ability for the cloud, all the infrastructure and the virtual resources. I guess everyone in the room here has deployed vSphere, knows how all vSphere works.
Is there anybody who hasn't deployed vSphere? Cool. All right,
That's
just
good.
checking.
That's good news. Makes it easier. Obviously, from a vSphere perspective, one of the key things about when you're designing and deploying your vCloud is to make sure that your vSphere design's correct. If you don't get the vSphere design correct, then the cloud's just not going to run efficiently or correctly. You know, if, for example, you've got your storage design isn't set up correctly and you lose your storage, then you lose your cloud. It's standard vSphere designing. So, vCloud Director architecture. The vCloud Director product itself has been built for scalability, so you can scale horizontally. So as and when you need extra resource for the actual vCloud Director product, you can just add more cells. Using load balancers, you can provision these and just keep scaling out up until a limit, which is it 25 cells?
20, yes, I believe so. I'll check at 1.5 if that changed. But.
So obviously, as and when your resources, if you're having, say you're a web business and you're selling goods over Christmas, you can obviously, at Christmas period, you can build out more cells for your cloud so you can start deploying more resources when needed. So you're able to span the load and then reduce it when you need to as well. It's obviously hardened for security. From a public cloud perspective, obviously vCloud Director, the web interface can sit on the internet and it's secure for that. It provides multi-tenancy support, and with the ability to scale out horizontally as well, it provides us with the ability to limit the single points of failure. So to cover the scaling a bit further, obviously the cells, as we were saying, you can scale horizontally. You can add the load balancer in front of the cells. One thing to note, though, is the vCloud Director shares a single database. So when you're designing your infrastructure for your cloud, you obviously need to consider making your database resilient. Because if the cells are all stateless, so if you lose a cell, then it's not critical because the other ones will take up the work and the load. But if you lose your database, you lose the whole cloud infrastructure, or the whole cloud front end. So the other great thing about VCD is the way it's been designed is that one cell can access many vCenters. So obviously you're limited to what the limits in vCenter are. So if you need to span out, you can expand into multiple vCenters. So when you're hitting the limits in vCenter, you've either got too many hosts, too many clusters. You can start spanning out and building more vCenters and more clusters, and they just add into the cells. So you can scale the vSphere resources as needed as well. So the logical architecture overview. So the reference architecture that we've put together as VMware is basically what we do is we build out multiple clusters. So we split these out into a management cluster and a resource group. So in the old days, for anybody who was here last year, we used to call these pods. So the management cluster is designed to host all the VMs that you need for running your cloud infrastructure. So your VCD cells, you've got your vCenter for the management cluster, your vCenter for the resource groups, your database servers, any syslog servers, or AD or anything like that. The cloud resource groups are purely for the resources for the cloud. So you build out a separate vCenter and you add those purely for management and resource contention. So if you were to think of having your management cluster and you have all your cloud VMs running in there, and then you're also using that as a resource cluster, then you can start running into contention the way that vCenter and VCD manage the resources. So you split it out entirely into a separate group for your resource groups at all.
So, yeah, this is a slide that we like to spend a couple extra minutes on, mostly because we get the question a lot from customers like yourselves that say, I've got vSphere, I've got 1,000 virtual machines, how do I put cloud on top of that? And what you'll notice from this diagram in particular is we're saying the opposite, right? You've got to stand something up to the side of that for the cloud resources, and we can move things over. What you can do is you can run your management infrastructure in your existing vSphere environment. There's no problem with that if you've got a production vSphere environment. But for this resource side of it, where we've got our precious metal tiers, if you will, that's typically separate clusters, new clusters. So there's a misconception that we can umbrella an existing infrastructure with vCloud Director. And for those who have installed it, and I'll point to some people in the audience like John, but there's different constructs. The vApp constructs are different from in vCenter. There's different ways that it gets controlled. And what you'll notice from one of the previous diagrams on the architecture is we've really started to build a web tier and an application tier. And the application tier is really Virtual Center, right, from an architecture perspective. So Virtual Center is really moving back in the stack a little bit. So it's becoming the engine behind vCloud Director. So we can lose things like a single cell. We can lose a web server and still continue to run. One thing we kind of do want to point out in some of this in the management infrastructure is if you're looking to do this in production, you've got to protect all the components, right? How many of you guys have vCenter running, right? How many of you guys have vCenter Heartbeat running? Right? So if you're looking at this architecture, one thing you have to think about is if you have a single vCenter and, say, 3 vCloud Director cells, what happens when you lose the Virtual Center? Right? We can't issue any commands from vCloud Director. Your users can get to the portal, and they can say, spin me up a VM, but if Virtual Center is not available, you got to start to think about that. You have to protect every tier in the environment, from the database to Virtual Center's database, vCloud Director's database, multiple cells. It becomes a very big architecture. We've got a couple customers I've been working with that are doing production, like service providers and some other people, and we've done that. We've doubled up everywhere we can to try to protect every component as best we can, humanly possible. And eventually we still have to contend with the burning crater scenario. But keep this in the back of your minds, because it's a very good, simple picture, but it really illustrates how we want to separate pieces, both from a security perspective, which we'll get into later.
So we're going to cover some of the vCloud Director concepts now. So one of the critical ones are virtual data centers. We obviously call them VDCs. So what is a virtual data center? So we have provider VDCs. Now these are a single type of compute resources, a single type of storage resources. And what we do with these is we create these to segment the resources based on the resource characteristics. So what does that statement actually mean? So basically, if you look at it along the lines of particular hardware, particular types of storage, so your Tier 1, Tier 2 storage, so your SSDs, maybe your SATA disks and your storage arrays. So we would build a PVDC out purely based around those storage and compute characteristics. So you don't mix your storage between them. So the way vCloud Director works is when you're adding your storage in, it doesn't differentiate between different types of data stores. So if you've got, if you mix your SSDs and your SATA, you're going to have some VMs that run particularly well on SSDs, and then they're not going to perform as well on the SATA. So you isolate those in a provider VDC.
So just looking out, and I see some nervous stares that we don't do storage tiering inside vCloud Director. We don't, but what we can do, and there's customers out there that are doing this, vCloud Director itself as a product can't distinguish, right? When you present 5 data stores to it, it sees 5 data stores. What you can do is you can use storage tiering inside the array technology, right? Things like fast pools, NetApp's got some technology. So we actually push that down to the array, and then we present that virtualized storage up to vCloud Director. And we have some ways we try to track that, from a chargeback perspective. But yes, independently, if you make the mistake of creating a data center with 3 different tiers of storage in it, vCloud Director is not going to know where to put that stuff. It's actually better served to be done in the storage array anyway. It's probably more efficient at it. So don't be nervous. It's okay.
And one of the key things as well when you're looking at building out the cloud and designing the cloud is we recommend that all provider VDCs are mapped directly to clusters rather than a root resource pool. And that's basically to reduce the resource contention and the ability that people can come in and change the shares. If somebody logs into the vCenter for the resource groups, people can obviously come in and change the shares on the resource pools, whereas when it's mapped directly to a cluster, that can't happen. Now, going back to the architecture, that's one of the other key reasons why we recommend that you split out your resource groups into their own managed vCenter, purely so people can't go in and start making modifications. You have a very limited set of admins to that vCenter. And I think with 1.5 and vSphere 5, when you log into that vCenter, it actually pops up a box telling you that this is managed by something else. So be aware of that.
You can still click past it, though, if you really want to. It's just an "Are you sure" button. Are you sure you want to make this mistake?
An organization VDC, which is an org, we also call them org VDCs. What this is, it's actually a subset of the resources from the provider VDC. So if you imagine your provider VDC is your pool of resources available, then an org VDC is a subset of those resources that you allocate to an organization. So if your provider VDC has, say, for example, 100 gigahertz of CPU and 10 terabytes of storage, you can then say for an organization that they can have, say, 10 gigahertz and 1 terabyte of storage for that organization. So it's a subset of the resources provided by the provider VDC. So there are obviously two different layers of compute resources. Provider VDCs are also used to define performance levels, so as we were saying about the storage tiering, but it's also for the HA redundancy, and you also use them to group your specific hardware. The org VDC, as we were saying, is a logical container for the resources for the organization. So again, that's a subset of the resources available from the provider VDC. So this is a graphical representation of what I was saying. To obviously, pictures speak 1,000 words. So as you can see on the left, we have the gold service provider, and we have the silver service provider. Gold service provider VDC and the silver service provider VDC, and they're split out into different org VDCs. So you can see that the gold has tier 1 storage and the silver is tier 2 storage, and they're split out to provide the organization with the options so they can use the different types of storage. So when your consumers come into the cloud, they can obviously select which storage tiers and which compute resources they want to use.
Yeah, I'll add something to this. So this is another area where we run into a lot of confusion, where customers ask, they have this perception that the organization has to be a one-to-one mapping to a provider. And that's not the case. You could have, and we see this obviously all the time with the service providers, but you can have one organization that's maybe HR, and HR can have access to the gold provider and the silver provider. And you can give them resources from both of those, and then they can make the choice where they want to drop their application. They may have some database applications that they want to put on Tier 1, and they may have some stuff that they want to put on Tier 2. We've got other customers that don't give them the option. The IT department says, no, this group is going to only have access to silver, because we feel they don't have any applications that are going to be beyond that. Those are decisions that have to be made during the design process, but it's flexible enough that you don't have to really get mired down into one particular thing. And I actually like this diagram because it shows that you can cross over, right? But each organization is still independently secured. That's where the multi-tenancy is. So just because we've got, in this particular diagram, operations and engineering sharing resources on the silver provider, that doesn't mean they're actually using the same networks. Doesn't mean that they're using the same firewall infrastructure. They're separate organizations. They have separate login boundaries. They're separate URLs for their APIs. So from that perspective, they're independent. The only thing they're sharing is compute and memory. So keep this picture too. And I know you guys are taking pictures, but I think these will be available too, so you can grab the presentations afterwards usually. Some of these are good reference charts.
So we're going to cover allocation models and have a bit of a deep dive into the allocation models, what they do and how they work and how they fit in together with the different VDCs as well.
Yeah, so we roll from VDC, virtual data centers, into allocation models because the virtual data center is created when you pick the allocation model. So they're somewhat one and the same. Two different terms, same object. So it gets a little more confusing, right? So what is the definition of an allocation model? It's how we define the resources. It's exactly how we're going to carve up the individual organization VDCs, and we have a couple of options that we can pick. It's what creates the resource pool. So Dave mentioned earlier that when we create the provider level, we point the provider to the cluster. We're allowed to point it to an individual resource pool if you create it that way, but what starts to happen is we've already created a parent resource pool, and when we distribute our allocation model, we create another sibling or child resource pool below that. And then we continue down that path. So who doesn't know Duncan Epping and Frank Denneman? Okay, they have a big section in their book called Sibling Rivalry, right, around resource pools. You have to understand that concept because everything in vCloud Director, when we create org VDCs and below the provider level, is all done in resource pools. We don't set shares. We keep shares equal across the board, but we want to try to avoid as many parent, child, and sibling situations as we can. So it is set on a per org VDC basis. We do, in some cases, set reservations, but like I said, shares we stay away from. So there's 3 types, and each of these actually map to a chargeback model too. So if you are looking to do chargeback and showback, each of these in chargeback 1.6.1, which I think is the current version, does have a mapped billing model as well. So you can actually parallel these to how you would bill. So let's start with pay-as-you-go. Pretty simple. Pay-as-you-go, the use case typically for pay-as-you-go is transient workloads, things that you want customers to spin up quickly. Your consumers want to use the resources for a couple of days. They're going to drop it off. Very hard for an organization that's using pay-as-you-go to budget for it, right? Because as the provider, they're going to spin up 10 VMs today. They're going to spin up 2 tomorrow. They're going to destroy 3 of those the day after. It's like trying to guess what your gas bill is going to be in New Hampshire in the middle of winter. You can't figure it out. So you go on a budget, right? The budget plan, if you will, from a billing perspective, is more around the lines of a reservation pool. Reservation pool is set. So as the provider, and some of you guys and some of you folks in the room are probably both providers and consumers, you're going to fit both of those bills. The reservation pool will create a resource pool in Virtual Center with reservations and limits set to be equal. So you pre-reserve and pre-carve out the resources for that organization, which means my original example, like HR, they might have some database infrastructure that they want to guarantee resources to. You'd bill them the same every month. They're basically going to come to you and say, we will pay for 20 gigahertz of CPU and 120 gigs of RAM, and we're never going to exceed that. So you can give them a reservation pool. Send them on their way. When they hit the limit and they can't power anything on, they're going to call you back and say, we need to adjust. That's easier to budget for, right? It's essentially the same charge every month or every year, every quarter. Pay-as-you-go is going to fluctuate all the way through. Allocation pool is actually pretty popular because allocation pool is burstable. You're not setting, it's kind of the best of both worlds. You're not setting a particular reservation where it's capped, right? There's an actual ceiling on it. You're not leaving it completely open like pay-as-you-go where it's sort of willy-nilly. You're setting a percentage reservation. So you're saying, okay, we'll set aside a percentage of resources in the cluster for you, and you're not going to have the limit, right? We don't put the limit on it so that they can start to burst over it. And then you can charge for overages as the provider. So a lot of customers actually that I'm seeing will start in the allocation pool or the pay-as-you-go. Developers, that's a good use case for pay-as-you-go model for a VDC because they're constantly spinning and destroying and creating and destroying, right? Because you're testing. So another question that always comes up is what happens with each of these models when we look in Virtual Center? What does it look like? So this is an eye chart, and it's not meant to, I'm not going to go through every one of these columns. It's in here so that when you get the presentations, you can print this off. But what you have to understand is when you pick a particular allocation model to create a virtual data center, number one, you can't change it. So if you mistakenly create a virtual data center as a pay-as-you-go, and you want to flip it to, say, a reservation pool, you can't do that. You have to create a second one and then move any vApps over. So you have to figure this out sort of up front, right? And this is part of the reason why, is each model does something different in Virtual Center. The easiest way to look at this is a reservation pool is the simplest. It'll create a resource pool in Virtual Center. It'll set a reservation and a limit, and all the VMs are equal underneath it. That's actually a situation where the consumer can elect to actually change their shares on their own of the individual VMs inside vCloud Director. We actually push that control back to the consumer. That scares the crap out of me. But some customers want that. The pay-as-you-go actually makes the changes not to the resource pool. It's the exact opposite. The resource pool is set to unlimited. The shares are set to equal, but all the settings get individually applied to every VM. So, for example, when you create a pay-as-you-go allocation model, you're asked what speed CPU do you want every VM to be? Anybody know what the default is by any chance? I heard it. 0.26 gigahertz. 260 megahertz is the default. You probably want to change that.
You win a USB key.
Yeah, you win a USB key. Yeah, you want to change that, right? Because we've had customers kind of blow past that screen and start spinning up VMs that take a half hour to boot because they're only getting 260 megahertz, and it's a limit. So if you look at the VMs in that virtual data center, every VM will have a 260 megahertz limit. So it's cookie cutter at that point. It's pay as you go. So very, very different when you look in Virtual Center. So that's why I say you have to really understand what's going on the back end. And the allocation pool does something in the middle. It sets the percent reservation on the resource pool for memory and CPU, but it also sets a percent reservation on memory specifically on every individual VM. So it doubles up. So the resource pool has a reservation, and the virtual machines have a reservation. So if you're not comfortable with resource pools, how many people actually use resource pools today? How many people don't use resource pools today? I'm guessing because they're kind of, an animal to get your arms around, right? So what I always tell customers is, yes, we're doing resource pools, and I've had some customers sort of freak out because they don't want to use resource pools. They've never used them. Think about vCloud Director as resource pools done right, in a sense. It's taking the control away from you, and it's doing a lot of the calculations, right? You say, I want 50% reservation for this allocation model. It'll do 50% reservation. You can add hosts on the back end into vSphere, and that calculation will continue to work. As opposed to what we used to have to do, which was, I got 10 hosts, it's got 200 gigabytes of memory, I want to set 50%, that's 100, and then you add 10 more hosts, you got to go back in and remember to change the resource pool. vCloud Director kind of takes care of that as part of the automation piece. So this chart is, for reference when you get the slides, is what will happen to the resource pools in Virtual Center. The second slide is the impact on the individual VMs in Virtual Center. So again, I kind of hung on this for a little bit, but this is one of those nice charts you're going to want to print off and put in your cube before you make that decision on which VDC, or better yet, when you're having the design conversation with one of us or with somebody in PSO or somebody in your partner community. This is a very big design decision, because once you pick the data centers and you start deploying virtual machines, you can move stuff, but you have to take some downtime on the VABs to do so. All right, enough about that. On to networking.
Is everyone happy with the allocation models?
We will take questions at the end, too. So if you have a question, we'll try to leave 15 minutes or so. We got about a half hour.
So we're going to cover networking now and how the concepts within vCloud Director work with the networking side. So before we go on, we've obviously been talking about consumers and providers. So we basically dropped this slide in to try and help clarify what VMware actually means by a consumer and a provider. So a consumer is somebody who actually wants to come in and use the resources of the cloud. They don't care about the infrastructure, they don't care what storage is, what hardware it's running on, they just want to come in and deploy their workloads. So these are typically your development teams, your provisioning teams within an IT environment. The providers are the guys who are designing and building and deploying the cloud. These guys care what the storage is, they care what the hardware is, and they care what the network is and how it all fits together. So it's a critical concept as well when we're going forward, because a lot of the slides cover the definitions between the consumers and the providers. So I would call a provider within a private enterprise a cloud admin, basically. That's how I tend to define it. So within networking, we have three different layers of networking. We have the vApp network, we have an org network, and we have an external network. And these are managed at 2 layers. So they're managed by consumers, and they're also managed by providers. And there's 2 different types of the networks that are managed by the 2 different layers. So an external network is an external network that's outside of the cloud environment. So it's outside of VMware. So this is your physical infrastructure. And these, again, are set up by the cloud admins or the providers. It might be your networking team, or it might be yourself. We have organization networks. These are contained within an organization. We were obviously talking earlier about org VDCs. So how we allocate an org VDC to an organization. We also create organization networks so that the VApps within that organization that we're running can communicate with each other. And then we have a VApp network. And a VApp network is contained purely within a VApp. And this is always set up by the consumers. So when somebody comes in to deploy their workloads, they have the ability to create their own networks within that VApp. So an overview of external networks. So as I was saying, it's a network that's external to vCloud Director. It's obviously created in the vSphere environment as a port groups. And it can be either on a standard virtual switch or a distributed virtual switch. So the typical use cases for this could be internet access, it could be external infrastructure access back through to your AED or your DNS, or it could even be out through to a second data center. You also use it for things like backup servers and IP-based storage. So an organization network, as I was saying, it's contained within an organization. It can be connected to an external network. Within vCloud Director, we have a few types of networks that you can connect. We have direct or we have NAT rooted. So direct means it's just can access everything. There's no restrictions. There's no firewalls. NAT rooted is where we start using the vShield Edge devices to put NAT roots and firewalls on there and block the traffic coming through. So obviously an organization network can be, as I was saying, left unconnected. So it can also be left completely isolated and just internal to that organization. So there's no external connectivity out to an external network. And again, that's backed by network pools. And the VApp networks, these are inherently private and internal to the cloud. So this allows VMs to communicate with each other. And then you can also connect them through to org networks. And again, when you're connecting to an org network, they can either be direct or they can be routed using the vShield Edge devices. And they're all backed, as I was saying, by network pools on the vSphere side. So, network pools, these are obviously a set of pre-configured network pools on the vSphere side. And these can be used to facilitate the VM to VM communications. So we have 3 types. We've obviously got the standard port group backed in vSphere, we have VLAN backed, and then we have the vCloud Director network isolation backed. So obviously port group backed, pretty straightforward for everybody who's created vSphere. These are just your standard vSphere port groups that you create. VLAN backed, again, it's exactly like port group backed, but vCloud Director will automatically create the port groups on the fly as and when is needed. But you have to stipulate a range of VLANs. So when you're setting these up, obviously you need to go to the network teams and say, I need X amount of VLANs, and you need to pre-configure these. So there's obviously can be a bit of a delay getting your network teams to do these. And then you have what we've got called the vCloud Director Network Isolation Backed, or the VCDNI. And this is our proprietary network isolation technology that we use the Mac in Mac encapsulation. So the port group backed, it obviously requires pre-configured port groups. So one of the big disadvantages with this is you obviously need to create all these port groups before you start configuring them in vCloud Director. So there's no creating these on the fly. You have to manually create these all the time. They obviously need to be kept in sync if you're using standard virtual switches. We've all worked with vSphere and previously VI3 with the vSwitches, where you have to create them and make sure all the names are the right case and everything, and this gets complicated with large clusters. And you need to ensure the isolation port groups rely on VLANs for layer 2 isolation. But one of the good advantages of this is it works with both types of vSwitches, so you can, with all virtual switches, sorry. So they also work with the Cisco 1000s as well. VLAN backed. So it requires a distributed virtual switch that's connected to all the hosts in the cluster, and it needs a range of unused VLANs. So again, as we were saying, as a VCD admin, you need to create these port groups. You need to have a range of VLANs configured. So you would go along and say, I need X amount of VLANs. So the example shows 10 to 15. And then so the advantages of this is you can isolate your networks within vCloud Director, and it provides best network performance. But the disadvantages is you obviously have to provision these VLANs beforehand. You also have the VLAN limitation. So if you think of deploying very, very large clouds, obviously from a VLAN perspective, you're limited to 4,096. And this actually states that it's not compatible with the Nexus 1000V, but once 1.5 goes GA, it will be compatible with the 1000V. And then we have the vCDNI, so the vCloud Network Isolation backed. Now, we think this is what makes cloud cloud. It's the ability to provision networks on the fly without any administration overhead. So how does it work? Basically, you allocate a transport network to VCD. So when you're configuring your cloud and you're creating your network pools within the cloud, you can come along, have one layer 2 VLAN that's completely isolated, non-routable, and you've specified to vCloud Director that this is your transport layer. You don't have to use VLANs. You could do it if you're thinking of creating a physical network with a few uplinks, just dedicated one VLAN. So the advantage of this is you don't have to use VLANs, but you can optionally set a VLAN ID, leaving it blank, and it allows you to use the vCDNI network technology to create networks on the fly using the MAC-in-MAC encapsulations. So the MAC-in-MAC encapsulation, how that works, is the packet is sent out with the MAC address of the destination ESX host. When it comes in, there's an agent that runs on the host that looks at these packets. It strips off the original MAC address, and there's a network ID for internal to the vCloud Director. And it looks at that network ID, and then there's a MAC address for the destination VM, and it routes it accordingly. So there's a few disadvantages. There's a small performance overhead on the hosts. So utilization on the host is about 1%. Now, my opinion is with modern CPUs that we have in 1% of utilization on a host is very, very low. So I don't think it's too much of an issue. You have to increase the MTU. So the default is 1500. You need to increase the MTU to 1524 because of the extra packet size. Now, if you're using jumbo frames, that's not obviously going to be an issue. So vCDNI is for layer 2 adjacency, so not for routed networks. And you can't have VMs on an internal vCDNI network going out on that same network talking to physical infrastructure, for example. It's only for internal to the cloud. If you need your VMs to talk to external infrastructure, you then route it through the different networks to the external network.
So, picture's 1,000 words again, right? What does all of this stuff look like when we actually draw it out? Each of these numbers represents a different object that David just spoke about. So one thing you're all going to notice is networking has a lot of options that you can create. So the easiest thing to start with is, and we won't go through every one of these because I want to get to the use cases and the questions, but you'll notice the organization network that is firewalled through a vShield edge to the external, or we can have a direct connect, right? In some cases, we do one or the other. In some cases, we do both. This is just to represent that you can have a vShield edge. It's not required, though. We got that question yesterday. vShield Manager is a required component of vCloud installations, but some customers don't ever spin up a vShield edge. They never pick a NAT-rooted network. Sorry. I got to get a laugh somewhere at your expense, right? You can do it later to me. So understand that it's how you decide to set it up. Now, to David's point, if you're using vCDNI, vCDNI is contained within the cluster. It's contained within the distributed switch. It's for host-to-host communication only. So if you've got vApps that are inside a vCDNI network that need to talk to AD or DNS or something that's external to the cloud, you're going to have to route that through a vShield Edge to get out to the external network. Another quick example is the vApp networks, right? So we've got a few examples of vApp networks down here, but again, we have options. We can put a vApp network through a vShield Edge to connect to an organization network. We can have a vApp network that's directly connected to that organization network. You'll notice you can also get into some situations where you start to double and triple route. If you had this vShield Edge connected up here, you'd have a double NAT, right? You can get into that situation. It's pretty easy. And then how do we do inbound communication, right? We have to actually really understand our networking. I set this up in my lab, and I think I gave myself a headache after about 3 hours. The first time I started playing with this about a year ago. So it's a difficult thing to try to figure out. Do you want a NAT? Do I have to NAT? Do I have to NAT everywhere? You don't want to not do vShield Edge every place, because vShield Edge is how you get your multi-tenancy. That's how we do the isolation between organizations. So at a minimum, we typically try to set up the organization networks that look like this. If this was two side-by-side organizations, if it was Coke and Pepsi, right, they would both not want to talk to each other. We'd isolate them from this layer, from this external layer, but that external layer could be common to both of those organizations, to both of those tenants. There could very well be services out there. We see service providers actually creating an external network and then creating what they call an external network. So they've got one that's external to the organizations where shared services might live. Typical thing might be recursive DNS, SMTP relay, things like that they're giving to their consumers. But then they've got real external network connectivity for things like VPN access back to that customer's data center for hybrid cloud, right? They don't want to pass that through, so they've got multiple connections to two different external networks. It's all on how you define it. Who's dizzy? Cool, that was my intent. So, no, it's the idea is to get you thinking about it, right? Yeah, if David and I are dizzy too. My hair stopped growing about 6 months ago. My wife told me when she looked at the back and there was nothing left. So here we go. Real customer use case. Put some of this in perspective. This was a really interesting use case because they wanted to do some stuff that I hadn't even tried yet in cloud. They actually did not want to use static IP pools. So when we talk about addressing and pooling and VLAN backed and all this other stuff, we also have network pools. We actually plug in ranges of IP addresses, and we can issue static IP addresses to all the virtual machines inside the cloud. They didn't want to do that. They wanted actual manually assigned IP addresses. The use case was because they wanted to actually deploy every vApp to be identical. They did not want to do customization. They were doing 180 degrees from what everybody else wanted to do, which is what made it a cool use case. So they wanted multiple levels of testing. It made it ideal for vApp networks, those real low-level isolated networks. They did have external communication that actually had to come into the cloud from HPUX, from web services, from databases. They had to drop items out into code repository. So we were talking a lot of external VLANs, multiple organizations. So what did we do? So some of this is going to look a little like the other diagrams, but you're going to want to take note of some of these ranges because it gives you a little bit of an idea. So we created an external network for every organization. We created a net new VLAN, empty subnet, made it easy for us to deal with so that if you go to the networking guys and they say, well, you can have these 10 IP addresses over here and these 5 IP addresses over here. No, that just makes our life miserable. Empty VLANs, brand new subnets make things a lot easier. We put a vShield Edge on it, so this is an example of a NAT-routed org network. And the use case here was that we had two developers working on two different components that needed to talk to each other. So we had developer 1 and developer 2 that were actually writing different pieces of code, and they needed to cross-test that code between their pieces, essentially. So this is actually what we created for the master organization. So we started to set this stuff up, and each of these went into a catalog. So this catalog was going to grow to about 100 vApps total, right? And it was an end-to-end catalog. Every vApp was configured. They could deploy every one of those components and run it all together as one giant application. So once it went into the catalog, we gave it some of these IP addresses, and we actually statically assigned the IP ranges behind the vShield Edge. And then we stuffed them into the catalog, and we set the catalog to not allow customization. So when a developer was going to deploy this, so we set up a second org. So we had a first org, which was the operations organization where the catalog existed. And then we started the next set of orgs where the developers could actually deploy. And it looks on the surface like it's exactly the same, but the only difference is we changed the external network range. So everything on the internal side was the same. So when we went to go do our NAT routes, if we needed to NAT route to .16 and 17, it was always .16 and 17 every time we deployed this. So, and they wanted to keep basically continuing this org structure all the way out for different layers of testing. They were going to go to about 20 different orgs. But they all had to be identical. Very, very different use case for cloud than what most people are thinking. On the inside, everything stayed the same. So the developers never had to really remember different IP addresses behind the edge because it's NAT routed. We didn't have to change it. It's perfect. All we changed was the external. Then what we did is we continued this on. So this is just another example. It looks the same, but we added a third organization with a third external subnet range. We just kept moving. What we then did is we said, well, developers did have to work on the same component. Okay, I can't really deploy those on the same segment because if they both spin up the same component with the same now internal IP addresses, I've got an IP conflict. vApp network, perfect. I can isolate their individual version of the vApp with their own vShield edge. Now I've got developer 1 and developer 2 working on the exact same component out of the exact same catalog with the exact same IP addressing, but they aren't conflicting with each other. And their one-to-one NATs automatically got created in that situation. But everything else was always net the same, right? They didn't have to think of anything different. And these guys were working on the same component for different projects, different stages of different projects. So it made it a really, really good use case. And this was all obviously a third organization with a third external. Now what you'll notice, these happen to be vApp networks. Look at the pen while I'm trying to, it's like looking down the barrel of a rifle. This vShield edge is actually connected to the external. So this is one of those examples from the first one where you have the option of saying the vApp network can connect to the org network or the vApp network can go straight to the external. We wanted this to go straight to the external because the external is routable and they needed to be able to get in through SSH and RDP and things like that. See a lot of nods. It's starting to click, right? It's starting to make sense, hopefully. And then we'd have, obviously, in the same organization, we could have a totally different developer, or actually, in this case, the same developer. Developer 1 was also working on component 2, right? So he was able to get to everything he needed to either through remote console or through SSH or IDP. We did not customize. That's what made this unique. Most customers, especially service providers, obviously, every time something's deployed out of catalog, it would normally be customized. You would sysprep, you would change IP addresses, get in, and it would be individually join it to the domain. They did not want that. They set it up once and they walked away. So we got about 15 minutes, so I'll roll through the design outcomes and we can get to the questions. So what we ended up with was a base catalog that had their base OSs. Then they would customize them initially in the operation side of things, put those into separate catalogs, and then allow the developers and everybody else to deploy from that. So this is, admittedly, remember we submit these things about 3 months before VMworld, 4 months before VMworld. So these were the use cases for 1.01. Some of this is starting to shift with the announcement of 1.5. People are starting to look at more pre-production, more, I think, this time next year you'll see production up there and you'll see limited production drop off. So compute on demand, testing, staging, still valid use cases. So we did add this for the case of 1.5. Dave and I tried to do our top 10. We couldn't come up with 10. We came up with 9. So here's our top 9 new features from the announcement with vCloud Director 1.5. How many people have been waiting for SQL support? Yay! Right? I was waiting for it in my lab because I was tired of messing with Oracle because I don't know Oracle. vShield Edge with VPN and static routing support. Huge, huge, huge addition to the vShield Edge. This is what's going to enable hybrid cloud to some of our partners, right? To be able to stand up vShield Edge, configure the VPN inside the vCloud Director APIs instead of going to the vShield APIs. Static routing support solves a lot of our inbound communication one-to-one NAT issues. 5-tuple firewall for actual security firewall rules for certain customers. API callouts, Elastic VDC. How many people are Lab Manager customers? How many of you were waiting for fast provisioning before you started to play with cloud, right? Because of the storage requirements. Okay, so that's coming. And obviously vSphere 5 support. And we did add we say third-party VLAN backed in VCDNI, but it's really Nexus 1000 will be the first one that you can do. What's that?
So I was just going to say, one thing to bear in mind with the fast provisioning is, although 1.5 supports fast provisioning, you need to use vSphere 5 to enable it.
Yes, yeah,
you can't use 1.5 with vSphere 4.1 for the fast provisioning. It has to be vSphere 5.
So that's pretty much the end of the slides. We could take some questions for 10 minutes. I do want to ask that we are doing this a third time this week. So for me, the surveys are very, very important because we've already made adjustments to this to get it down to timeline-wise and be able to stay on certain slides. So please hit the mobile app, fill out the surveys for us. And with that, we can, I know some of you guys are going to funnel out to go to other sessions, but we would like to take some questions for the last 10 minutes. There is microphones, I think, in the aisle. That we can turn up since people are going to be funneling out. It'll make it easier for us to hear. That's our contact info, by the way. You can take a picture of that slide. I need more followers. I'm trying to beat Duncan, but it's going to take me a while. Come on.
Yes, sir.
Link clones is fast provisioning. It's the same thing. Yes, sir.
How easier is it possible to change network types? So I see a scenario where some people will go and I'm a network guy. People change their minds all the time. So they'll go and say, this doesn't need to talk to the outside world. And then, the angels descend upon their heads and say, oh, wait, I've had a revelation. It needs to talk to the outside world. So now I need to convert it from a totally private network to NAT converted.
It's actually pretty easy. If the cloud provider sets up the network that they need, the org administrator or the vApp administrator can actually flip the networking on the vApp and the VMs. Somebody's just got to actually create the network for them to see it, and it's just a matter of changing it and powering down and powering up the VMs to reassign the IPs, and it'll be good to go.
Okay.
It's pretty easy. Yep.
Good morning.
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 The vShield Edge editions in the 1.5, do those include anything around IDS or IPS type of
I
intrusion?
don't know. That's a great question. Can you do me a favor? Can you post that to Twitter to the hashtag CIM1264? We'll find out and we'll reply back.
Blink, 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 blink. What? Post it where? I'll come talk to you.
Yeah, come talk to us. And if you guys have questions that we can answer, every one of the sessions, if you didn't know, has a Twitter hashtag. So if you take the session ID and put the hashtag in front of it, we're following those streams for questions and stuff.
So we're running on a trial license with the of 1.0 and have an Oracle database. Is there a converter that's going to show up to move it to SQL, or are we going to strip it back down and start over?
There's always one guy in the crowd.
I'm sorry.
No. It's a common question. I have my VMware shirt on, so I will use my VMware standard answer. VMware is not supporting today a migration from Oracle to SQL. Customers can try it. They will be on their own. If you call GSS, you're not really going to find very much support on it. And primarily, it's a chicken or egg situation because you'd actually have to move from 1.0 to 1.5 to upgrade the database tables on Oracle first before those tables would be able to get shifted over into SQL. I hate to say it, but you're on your own. It's a tough place for me.
That's kind of what I figured the answer would be.
Yeah.
So, thanks.
Was that a nice enough answer, though? Sure. Okay. I could have just said no.
When consumers self-service a virtual machine, do they choose the data store to place that virtual machine?
No, there is no. That's part of what makes cloud, right? The consumers don't actually see the data store, so they see the virtual data center that you've provided to them. So they've got to know that if you've given them gold and silver, that gold is EFD or Fibre Channel and silver is something else.
And is that tied to a data store cluster construct?
No, I think no. Storage DRS is not supported with 1.5 yet. It won't be.
That's on the roadmap?
I believe so. If you post that, we can see if we can get some information from Eddie. But yeah, it's everything's coming, right? It's a progression since vSphere 5 is new enough that they just didn't add storage DRS yet.
Thank you.
Good question, though. We get that a lot. Other questions? Yes? No?
Any more?
Cool.
Okay, thanks for coming.
Thanks for coming at first thing in the morning.